Hi! In this video, we're gonna learn about formation of ionic compounds. Now let's learn how are ionic compounds formed using the Lewis Electron Dot Structure. Let's first define what's an ionic compound. An ionic compound is a compound that is formed between a metal and a non-metal. In other words, we know that the metals are the ones that readily loses electrons. So the metal, when they lose the electrons, the non-metal gains them. So simply stated, ionic compounds are formed when there is a transfer of the electrons, in which your metal is the cation and the non-metal is the anion. Let's recall that in the periodic table, we know that we have to locate where the metals and the non-metals are. We know that in the periodic table, the non-metals are the ones on the right side of the metalloids, and the metals are the ones on the left side of the metalloids. Kindly recall, where are your metalloids? Usually, they form your stairway. There are 7 metalloids that separate the metals from the non-metals on the right side. Now take note that hydrogen is the only element on the left side that is considered a non-metal. So how do we now visualize the formation of ionic compounds between the metal and the non-metals? On your screen, you will see an example of 2 elements, potassium K and chlorine Cl. So these 2 elements, when we locate this in the periodic table, potassium is found on the left side of the metalloids. Therefore, your potassium is your metal. On the other hand, chlorine is located on the right side. Your chlorine is your non-metal. Therefore, these 2 elements form your ionic compound. Let's illustrate how the dynamics of the formation of K and Cl will form. Now, we know from the previous definition that the metal is the one that will lose the electron and the non-metal will be the one to gain the electron. Now, always take note that in a formation of ionic compound, the metal should be written first and then the second will be the non-metal. Or the cation is first and then the anion is second. So how does this work? So we know that potassium belongs to group 1 and all group 1 elements have 1 valence electron. So drawing the LEDS or the Lewis Electron Dot Structure of 1 dot for it to signify or represent the 1 valence electron of K. On the other hand, chlorine is in group 17. Group 17 elements have 7 valence electrons, and so the Lewis Electron Dot Structure of chlorine is drawn this way. So you are seeing 3 pairs of electrons and 1 lonely electron. And so we know that because this is the non-metal will have to gain the electrons. So what's gonna happen now? Now on your screen you will see there is an arrow that is drawn. Now what does the arrow mean? The arrow represents the transfer of the electrons from the metal to the non-metal. Now remember that the metal here is potassium, and since potassium only has 1 valence electron, so it can only lose 1 electron. So when this electron gets lost, the non-metal will receive or of potassium. So we know that chlorine has initially 7 electrons, and based on the octet rule, chlorine will have to gain electrons so that it can have 8 electrons after the gain. So because it has 7 initially, potassium here will fill out and add to 1 electron here to the lonely electron of chlorine to make chlorine have 8 valence electrons, which is what it was looking for initially. So what this transfer of electron, 1 electron goes to chlorine. So the will be this. Your potassium, because it loses one electron, it's gonna become K plus. Plus or just plus 1, it can be plus 1 or 1 plus. It means that your potassium lost one of its valence electrons, so it becomes K plus. On the other hand, chlorine becomes Cl negative or negative 1 or 1 negative again. So if you see in the drawing on the screen, K no longer has dots because it has electron, and chlorine on the other hand has an added 1 electron, which is represented by X here, thereby making chlorine having 8 valence electrons. So now that we know how the transfer of the electrons occurs between potassium and chlorine, because we know that potassium can lose 1 electron and it becomes K plus, and Cl will need only 1 electron to all in all, so therefore its charge is negative or 1 negative. Therefore, we can already generalize what is the ratio between K and Cl to make a stable ionic compound. That we know only 1 potassium is needed to make chlorine have 8 electrons. So therefore, the ratio of K and Cl is KCl. We call this the chemical formula of your ionic compound. So K, being the metal, is written first. There's only 1 K and then 1 chlorine being the nonmetal. Now take note, when we chemical formula will show you the elements present in the compound, and in terms of written first followed by the nonmetal, or it can be said that it's the cation first, the positive, and then the second one is the anion, the negative. Now, in terms of quantity, the subscript will tell you, the subscripts are the numbers after the symbol of every element. Any subscript for K and Cl, it's understood that it's 1 each. K for every 1 chlorine. So that is how we're going to write the final chemical formula of the formation of potassium and chlorine ionic compound. So that's it. This is just a very short video to illustrate to you how an ionic compound is formed, transfer of the electrons from the metal to the nonmetal. Thank you. Bye for now, and please don't forget to like, share, and subscribe to my channel, and leave some comments if you have some insights about the video. This has been Madam Narca saying don't stop learning, relearning, and unlearning. Till next time.